Hello, I'm Teresa. Today I'm presenting my pre-processing project using Alter AI Studio. So first, I have my dataset 1. So our goal was identify and handle missing values to improve data quality. So first, the dataset was retrieved into Alter AI Studio and inspected for missing values. Some missing data were stored as the string none, so I used the replace operator and declare missing value to convert them into true missing values. So after inspection, the attributes with missing values were age, meal option, Wi-Fi rating, ticket price, and seat type. Among these, age and meal option had the highest missing rate at 37%, while passenger ID, ticket class, and satisfaction had no missing values because imputing over one-third of the data would introduce bias. Age and meal option were removed. For the remaining attributes, missing values were replaced using the minimum value method to keep realistic numeric values. So after removing remaining incomplete records, we have a 25 clean examples remain, resulting in a consistent and analysis-ready dataset. So here, for my data set 2, the objective was to detect abnormal users or outliers in fitness tracker data. So first, I prepared the data by using select attributes to keep only relevant numeric features such as age, steps, sleep hours, heart rate, and calories burned. Then I applied Z transformation normalization so that all attributes contributed equally to distance calculations. So initially, I used the detect outlier distances operator to identify. Loof identifies users who are unusual within their local neighborhood, so it can detect different types of anomalies. So finally, to keep only the most extreme cases, I filtered the data using an outlier score greater than 1.5. These top outliers showed highly unusual activity patterns such as extremely high or low steps, heart rate, calories burned, or sleep hours. So overall, this process improved dataset reliability and helped identify meaningful abnormal user behavior.
Here, I will be taking part in explaining about data survey and data support. In the data survey, it is by calculating the average calorie balance for both female and male. Here, I apply two operators. These are pivot and renaming operator. Starting with the first one, I only use pivot operator for the first one and things like group by attributes or workout type and then column grouping attribute is gender and then as for the regression attributes as calories and average. And once I click the run, it shows like these are the results in the pivot table. And then the categories names are like average calorie female and male. So it is a bit messy and not clean to read. So I apply additional operator, which is called renaming operator. The results are like completely different. Female male for their category names and compared to the previous one, it is much more simpler and easier to know an ISO. Moving to the data form. It consists of sub-macro, HRAM macro, generate macro, simple for as for the operators. In the sub-macro, it is both defining the version macro value, and then in the HRAM macro, it extracts the data type into a macro, then in the generate macro, it calculates a new macro, like new data set, and the sampling part, it sample the data set using the macro value. Here in the sub macro, I only apply 0.4 for the fraction, which is a 40% of the original data set. When I click the run, the results are like a 45 example, which is a 40% of the original data example files. And then in the next one, there's a data set with 1,000 example, and I only use 0.75, which is 75% of the original examples size. And the results are like it shows only 750 examples, which is exactly 75% of the example. If I change this fraction value into 1, and then the result will be like 1,000 example, meaning that changing the sub macro value. Here, changing the sub macro value changes the sampling fraction, which automatically changes the final dataset size. And these are all my part.
Hello, I am Eleanor, and now I will provide a brief explanation of the answer for dataset 5. So for dataset 5, my task was to process employee data by controlling and comparing department sizes using macros and nested operators in AI Studio. First, the dataset was imported and the macro called MaxSize was defined to control the maximum number of employees per department. This macro was reused in the branch and simple operators, making the process flexible. Next, I used loop values to process each department separately. Inside the loop, filter example select employee from the current department and a branch operator check whether the department size exceeds the macro value. If it does, the simple operator reduces the number of employees, otherwise all records are kept. In challenge 1, I adjusted the maximum size by changing the macro value and the process updated automatically. In challenge 2, I used integrate operators to find the smallest department size, saved it as a macro, and sample all departments into the same size using a loop. In challenge 3, I added performance-based logic by calculating the average performance score and using it in a branch operator. And finally, challenge 4, I compared department sizes before and after processing using append and visualization. Thank you for listening.
Hello everyone. Today I will present dataset 6, employee promotion prediction. The goal of that is to use the supervised learning to predict whether an employee will be promoted in the next promotion cycle based on historical employee data. Okay, the data set contains 500 employee record with both categorical attributes such as developments and gender, and numerical attributes like including age, experience years, performance score, and training hours. The target level is promoted, yes or no. We build 3 classification models like decision trees, knives, and rule induction. Okay, the decision tree use a flowchart like structure and show that performance score, experience, and training hours are key predictor. Knives predict promotion using probability and visualize categorical data with bar charts and numerical data with line chart. Root induction create easy to understand if-then rules and making it most intuitive model. Across all 3 models, last performance score is consistency, the strong predictor of promotion. The consistency increase confidence in the result and show that employee performance is the most important factor in their promotion decision.
Now I will explain my dataset 7 and dataset 8. The dataset 7 is based on the passenger survivor data. In the challenge 1, I loaded the dataset into the AI Studio, set survive as the labels and train knife bias model using the 4 parameters. After applying the model, I obtained the predictions and confidence values that represent survival probabilities. In the challenge 2, I analyzed the prediction results and I sorted the data based on the survivor confidence and select the top 5 predict survivors. All the 5 passengers were female. So the percentage of female survivor was 100%. And in the challenge 3, I replaced the knife bias model with the decision tree to compare model behavior. I changed parameters such as splitting critations, tree types, and prunings. This resulted in more confidence rule-based prediction. In the challenge 4, I perform feature engineering by creating a new attribute called isAllow. I retrain the model and evaluate performance to measure the impact of these new features. And the dataset 8. The dataset 8 is focused on the model trainings and evaluation. In challenge 1, I split the data set into the training and testing set and trained the knife bias model using the training data, and the model was applied to test the data to generate prediction. And in the challenge 2, I evaluate the model performance. The test set contained 90 examples and the model achieved 100% accuracy with no misclassification. In the challenge 3, I used the breakpoint to inspect the data split and confirm that the data set was correctly divided into 210 trainings and 90 testing examples. In the challenge 4, I used the advanced performance metrics such as accuracy, classification, error, and RMSE. All metrics confirm perfect prediction performance. So in conclusion, both data sets demonstrate how model selection, parameter tuning, feature engineering, and proper evaluation influence prediction results. Thank you.
Commandant, and you can call me Hoogie. In I was taking dataset 9. In dataset 9, focus on elevating classification model using a cross-validation. The goal is to predict survival and ensure the model performance is reliable, not depends on a single data split. So first, the target attribute suffix was set as a label. Cross-validation were added. Right here, you can see cross-validation was used to split the dataset into the multiple folds, allowing the model to be trained and tested several times using different data partitions. In challenge 2, the numbers of folds was set to the 2. This means half of the data is used for training, the other half for the testing, and then they swap. Breakpoint were added to inspect the exercise of the training and test sets. And then robustness and for the result. Most of the robustness was evaluated using accuracy and standard deviation. A lowest standard deviation means the model is more consistent across folds. Normalization was added inside cross-validation to improve stability and avoid data leakage. So in conclusion, dataset 9 showed that cross-validation provides a reliable evaluation of model, and standard deviation is important for understanding performance stability. So for dataset 10, the RC-CAP plots. So in dataset 10, focus on comparing different classification model using RC-CAP and AUC-CAP instead of accuracy alone. The compare RC operator was used to train multiple classifier. It performed cross-validation internally, so a spread cross-validation operator is not needed. The RC-CAP plot true positive rate against the false positive rate. Model with CAP closer to the left corner perform better at distinguishing between classes. So AUC measure overall the model performance. A buffer classifier has an AUC of 1.0, while the random guessing has 0.5. The transparent region around ROC CAP show variability across fold, while narrower region indicate more stable model. So in conclusion, dataset 10 demonstrate how RC-CAP and AUC provide a fair way to compare model and select the best performing classifier.
In this project, I work with two datasets in Altair AI Studio, Booksy transitions and books. They describe which customer bought which books and for how much. I first imported both CSV files into my process. One file contained transition details, and the other contained both information like title, genre, author, and publisher. And I joined these two datasets using a join step with book sales transitions on the left and books on the right, and use book ID as the key. This gave me a single table where each transition was linked to its full books data. And next, I created a new attribute called to the amount using attribute generation step with the expression quantity into price per unit. This calculated how much money was spent in each transitions. So to make the data easier to read, I use select attribute data and kept only customer ID, titles, and total amount. This produced a clean view of who bought which book and how much they spent. Then I sorted the dataset by total amount in descending order to find the transition with the highest single book spending. And finally, I created another attribute called square total by squaring total amount. This emphasizes very large purchases and help highlight extreme spending in later analysis or visualizations. So overall, I joined the dataset, calculated total spending, simplified the columns, found the dot spender, and created a transform feature to better understand customer purchase behavior. And that's all my parts. Thank you.